now that I've cut my dados, I want to countersink some holes on the back side, because when I put the panels into these grooves, I'm going to want to make sure I can drive a screw through the opposite side and really hold it together. You see here on one of the bench pieces, I've already got those laid out and cut. They go a little ways into the material, and then there's still some meat for the screw to hold on to before it goes into the next panel. So that's what I need to do on all of these. Really, all the tools I need are a square. A framing square actually comes in handy because this is a pretty wide panel, and a pencil. I got my measuring tape here for good measure. So what I'm going to do is I'm going to find the center of this dado, transfer a line around to the other side, and simply indicate where I'm going to drill some countersink holes. I've decided I'm going to put one hole an inch in from either end. That's one, and since this is 15 inches wide, it'll be 14, and I'm going to have one centered, half of 15, 7.5, and all it's really going to take are those marks to indicate where I'm going to drill. You'll also notice pretty much any time I'm moving these pieces around, now that I've sanded them, I'm going to have them on some sort of a soft surface. The worst thing that you can do is have to backtrack, meaning you did a really nice job sanding, and then you lay it down on a table and you ding it up somehow because there's some sort of debris or material, or you whack it on something. So now that these are sanded pieces, they represent a fair amount of effort, and if you're counting your effort by, you know, money per hour, they have a certain amount of value to them. So to screw them up is really, if in a working situation, the sort of thing where you're going to be losing money. So it's smart for me to keep these as well protected as I can. Let's quickly talk about what a countersink hole looks like. There are three holes that you typically drill for a countersink hole. The first one is the top one. That is the countersink itself. This is the shape of the screw head, so it's wedge shaped, and it's going to allow the screw to sit at the level of the surface or slightly below it. The second hole you're going to drill is the clearance hole. The clearance hole is going to allow the screw to pass through the first board without getting hung up or biting into it. The third hole you're going to drill is called the pilot hole. The pilot hole is the same size as the shank of the screw, meaning that solid center part of it, but it is going to allow the threads to bite into the material. This will pull the bottom board up tight against the first board and create a really nice strong joint. Now I'm ready to drill the countersinks on the opposite side of the dados. I'm using a 3/8 inch Forstner bit. This is going to allow me to use a 3/8 inch dowel to plug all the holes and give it a nice clean look when we're done with the project. I've also used my depth stop, it's on the opposite side here, you can't see it, to establish a specific depth that I want all of these countersinks to be drilled. So that'll save me a lot of time later. And now all I have to do is line up my workpiece and drill all these holes. My last move before I get ready to assemble this is to drill the clearance holes for my countersinks. So there are three holes that you have to drill when you're making a countersink fastening sort of a situation. The first is the countersink itself. This is going to allow the screw head to be out of the way, maybe flush with the surface, or in this case below it, so we can put a plug in afterwards. The next hole you're going to drill, the one I'm making now, is the clearance hole. I'm going to be using these 6 by 1 5/8 screws. This clearance hole is going to be a hole that's as big as the outside diameter of the threads. This will allow the screw to pass through without actually screwing into the material. The final hole we'll drill when we're assembling it is called the pilot hole. And that hole is going to be the same diameter as the shank of this screw. That will allow the screw's threads to bite into the material, but it won't let the shank of the screw expand the wood so much that it'll crack or expand and break. Okay, so I'm going to drill those clearance holes now, and then we're going to be ready to assemble.